Hey, what's up YouTube? Mr. Fackenthal here again, and today we're going to be talking about Chapter 6, Section 4, comparing linear and nonlinear functions. We've been doing a lot of work with comparing linear functions up to now, but now we're also going to talk about nonlinear functions and how they compare to linear functions. As you can guess, linear functions create a line, where nonlinear functions don't create a straight line. Alright, let's go. So our key idea for this lesson is that the graph of a linear function shows a constant rate of change. A linear function shows a constant rate of change. We knew that coming into this. But a nonlinear function does not have a constant rate of change. So its graph is not a line. It's not a straight line, okay? So let's look at a linear function would have a constant rate of change. That's going to be our lines like this. Okay? Lines that went straight up and down, just like this. Where a nonlinear function may look something more like, I don't know, see this? A nonlinear function would be a curved line, where a linear function is a straight line. Example 1 has us identifying functions from tables. So they want to know, does the table represent a linear or a nonlinear function? And explain. Well, let's look at Table A. Table A, x increases by 3 as it moves up. X is constantly increasing by 3, and y decreases by 8. So it's minus 8, minus 8, minus 8. So as x increases by 3, y decreases by 8. The rate of change on this is constant, so it is linear. And then if we look at Table B, from 1 to 3, that increases by 2. 3 to 5, that increases by 2. And 5 to 7, that increases by 2. So x constantly increases by 2. So we're off to a good start. But then if we go to y, we see 2 to 11 is 9. 11 to 33 is 22. 33 to 88 is 55. So as x increases by 2, y increases by different amounts. The rate of change is not constant. It's very important. Let's underline not. The rate of change is not constant. Therefore, this is a non-linear function. So if the rate of change is constant, it's a linear function. If the rate of change is not constant for both x and y, it has to be for both x and y. If it's not constant, it's nonlinear. Not constant, nonlinear. So example 2 wants us to identify functions from graphs. So they gave us two graphs here. We have graph A and graph B. And they want to know, does the graph represent a linear or nonlinear function? And it would like you to explain why. Well, let's look at graph A. Graph A is a curved line here, right? It's a curved line. It's not a straight line. It's not a straight line. So is it a linear function or a nonlinear function? If it's not a straight line, it is a nonlinear. It is a nonlinear function. Okay? It is a nonlinear function. Graph B. We have a straight line here, right? It's a line, therefore it is linear. So if it's nonlinear, it is not a line. If it is linear, it is a line. Example 3 wants us to identify a nonlinear equation, which can be written, which equation represents a nonlinear function. So out of these four equations, we want to know which represents a nonlinear function. Well, we want to think about what makes a linear function. A line is a linear function if it can be written as y equals mx plus b. If it can be written in slope-intercept form, y equals mx plus b, then it's a linear function. If it can't, then it's a nonlinear function. So let's look at A. A is written as y equals 4.7. This would make a horizontal line, right? This is one of our special cases. This makes a horizontal line. So this is a linear equation. So A would be linear. Equation B. Equation B is y equals pi x. Well, we know pi is a constant, right? Not a variable. So this would be the same as y equals mx, where m is pi. Therefore, this can be written as in slope-intercept form, so it is linear. This just wouldn't have a y-intercept, a plus b, just like this one wouldn't have a slope, mx, because it's 0x. Let's go to equation D. Equation D is y equals 4x, 4 parentheses, x minus 1. So let's rewrite that after we distribute this 4. So we're going to distribute that 4. That'll give us y equals 4x minus 4. This line is written in slope-intercept form, y equals mx plus b. Same thing, 4 is our slope, negative 4 is our y-intercept. So we're good to go. So this one is linear as well. Now let's take a look at C. Can we write C in slope-intercept form? Well, we have y equals 4 over x. There is no way that we could write this in slope-intercept form. If we multiplied both sides by x, we would have xy equals 4. Then you would try to divide both sides by x, and you would be right where you left yourself. So let's try it. So we have y equals 4 over x. Multiply both sides by x to cancel that out. So those would cancel, and then we have xy equals 4. Now we still want to isolate y, so it's in slope-intercept form. So if we divide both sides by x, that'll leave us with y equals 4 over x. That puts us right back where we started. So there's no way that we could write this equation in slope-intercept form. So it's going to be non-linear. So our original question, which equation represents a nonlinear function? That would be C. So example 4 is our real-life application. Account A earns simple interest and account B earns compound interest. So the table below shows the balance for 5 years. Graph the data and compare the graphs. Well, they gave us this table over here, and they tell us that 1 year account A is $100 and account B is $100. After 1 year, account A is at 110 and account B is at 110. After 2 years, account A is at 120 and account B is at $121, 3 years, and so on. So this is how we read that table. They also went ahead and plotted all these points on a graph for us. So if we look at this, we see the blue line is account A and the red line is account B. Now, just looking at this graph, we can already tell account A is a straight line, while account B is a curved line. It's not a line, it's a curved line. So we can already make the assumption that account A is going to be a linear equation and account B is going to be a nonlinear equation. Now let's just double check that by looking at the table. We see account A increases by, 100 to 110 is going to be plus 10. 110 to 120 is plus 10. 120 to 130 is plus 10. 130 to 140 is plus 10, and so on. Account B, on the other hand, 100 to 110 is plus 10. 110 to 121 is plus 11. 121 to 133.1 is plus 12.1. So we can already see account B does not increase, does not steadily increase. It's not a constant growth. It doesn't have a constant rate of change. Therefore, it's going to be non-linear. While account A, on the other hand, does have a constant growth, has a constant change, constant rate of change. Therefore, it's plus 10 plus 10 plus 10, it is linear. Alright, don't forget to like and subscribe, comment any questions you have below, or bring your questions to class. Make sure you get these notes done on time, you know when they're due. And it's also really important, if you had any questions on this, or if you didn't understand anything the first time, make sure you go back, you can pause the notes, copy everything down, watch it again, see if it helps you make sense a little bit more. We have a quiz and a test coming up on this very soon, so you gotta be ready for it. Alright, until next time.